Okay, let's solve falling weather problem. This is going to be y-axis. This is going to be x-axis. X-axis, y-axis. Let's draw a weather. Okay, so this distance is going to be y. This distance y. This distance x. And it's given in our problem that our weather is 13 meter long. It's also given in our problem that the bottom of a weather slides away from the wall at the rate of 1 meter per second. So this point moves at the rate 1 meter per second. We can write it's given that dx dt equals 1 meter per second. We need to find how fast the top of a weather sliding down. So we need to find dy dt. And to solve this problem we can use a Pythagorean theorem. We can write x squared plus y squared equals 13 squared. And in this problem there are like three functions. Let me draw those functions here. This is a ground function. That's a function of this point x with respect to time. It's a function of how fast this point moves with respect to time. And we can put 1, 2, 3, and we can say it's time in seconds, and here we can write 1, 2, 3 x in meters. That's a function of this distance, and it's given to us that this point moves at the rate 1 meter per second. We can draw this function like this. 1 meter per second means for every second it goes 1 meter. For every second goes 1 meter. There you go, that's a function. It's given to us that this point moves at the rate 1 meter per second. There is a second function going on. It's this point's function, y distance function. It's y, this is time, and we need to find how fast this point going. So we do not know this function. That's what we're looking for. We need to find dy dt. We need to find this function, how fast it moves. And there's a third function going on in this problem. It's this distance h. This distance h with respect to time. This distance h with respect to time, as time passes by, this distance never changes, because when the weather falling down, it's always the same distance. So this distance never changes with respect to time. This distance is always 13. And we can say dh dt equals 0 because it's a constant 13 and derivative of a constant function is 0. We can say dh dt equals 0. Okay, so to find this function, to find function dy dt, we need to differentiate this equation. And let's erase this. Let's erase this. And let's differentiate this equation. Show you my method of differentiating. Let's say x squared. There are three functions in this equation: x squared, y squared, and 13 squared. So I like to give it a name. I like to say x squared is my function m, y squared is my function n, and 13 squared is just a constant. It's 169. It's just a constant. So I just use a substitution. I name this function m and this function n, and this function for this function gives us this. So I just write like this. And now I'm going to differentiate this equation with respect to time. I do d dt of both sides, left side and right side. And you know, when you differentiate left side, ddt distributes into m and ddt distributes into n. So let's distribute ddt into m, and then we find what's ddt of m. So we write, and we know m equals x squared. M equals x squared, and we need to find dm dt. Need to find dm dt. And here we're going to use chain rule. We can find dm dx. Dm dx is equal 2x, and we know that x is a function of time. X is a function of time, and it's given to us that dx dt equals 1. And using chain rule, we can write that dm dt equals dm dx times dx dt. And dm dx equals 2x, dx dt equals 1. So dm dx times dx dt equals 2x times 1. Okay, now let's differentiate ddt of n. Let's find dn dt. We know that n equals y squared. N equals y squared, and we need to find y equals n squared, and we need to find dn dt. dn dt. And we're going to do exactly the same thing as we did here. We use in chain rule, and we find dn dy equals 2y, and what's the value of dy dt? Remember, y is a function of time, but we do not know what this function, some kind of function, dy dt. So we just leave it as dy dt, and using chain rule, we find that dn dt equals dn dy times dy dt, and it equals dn dy is 2y times dy dt. We do not know what dy dt, so we just write times dy dt. And to find derivative of this, right side, ddt of this right side is just 0 because derivative of constant is 0. So here we go. Pretty much we find out when we differentiate this equation ddt, we figure out that when we differentiate this part, when you take ddt of this part, we're going to get this term, and when you differentiate ddt of this part, let me highlight it, of this part, we're going to get this thing. And when you differentiate this part, it's just it's going to be 0. It's just a constant. So let's write it here. When you differentiate this equation, you get when you differentiate this equation, you get 2x times 1 plus this part 2y dy dt equals 0. And you can use this as a shortcut. You can just memorize this algorithm and use it as a shortcut. This is more detailed way of doing this, so you get really good understanding in depth what's going on, how you go from here to here. And now it's easy. All we need to do is find dy dt. So we leave this term on this side, 2y dy dt, and we move this term to this side, and 2x times 1 is just 2x. Move 2x to this side is minus 2x, and dy dt equals negative 2x. We divide both sides by 2y, so negative 2x divided by 2y. That's pretty much our answer, and I'll explain you what's the use of this formula. You can also simplify it, of course. You can write minus x over y. That's a nice final answer. Now let me show you what's the use of this. Let's erase this. Remember Pythagorean theorem, we had this equation y squared plus x squared equals 169, and if you solve for y, you get this y squared equals 169 minus x squared, and then you take a square root of both sides and you get square root of 169 minus x squared. Actually it's a plus minus square root of 169 minus x squared, but I'm not writing plus minus because it's a geometric problem, and when you solve geometric problem it doesn't make sense to talk about negative distance, so we only care about this positive square root. And one more thing you can do, you can use this final answer and plug it in this thing, and you get this dy dt equals we take this y and plug it in here, so we get minus x over, we plug it in this thing for y, so we got over 169 minus x squared. You can write your answer like this, and it's very useful form. I'll show you what's the use of it. You can make a quick sketch to the x-axis, y-axis, and this is our ladder, and we figure out that dy dt equals this. That's how fast this point moves, and you can find exactly how fast it moves. So let's say let's erase this, or we can just say, remember this is 13, this ladder is 13 meter long, and let's say when this point is 1 meter away from a wall, you can find how fast this point moving down. When these points move the 1 meter away, remember this point moves consistently. It's always moves with the rate 1 meter per second. But this point moves faster as time passes by, and you can calculate exactly how fast it's moving. You do like this, dy dt equals minus, you plug it in 1 into this equation, and you get 1 over 169 minus 1 squared. If you calculate this, you're going to know how fast this point moving when this point is 1 meter away from the wall. And you can keep calculating it. Plug it in. Let's say you wanna know if this point is at, when this point moved like 2 meters away from the wall, you want to know how fast this point moving. So you take this 2 and plug it in here. (169) minus 2 squared, and you can, if you calculate this, you can calculate exact speed of this point sliding down when this point is 2 meters away from a wall. And let's just check one more point. You can plug it in all those points. You can plug it in 3, 4, 5, 6, 7, 8, 9, and so on. And then you can also plug it in point 13. When this point is at point 13, that's pretty much when this ladder hits the ground. You can figure out at what speed this point hits the ground. You just plug it in 13 for x, and we get square root 169 minus 169. Yeah, so this equation doesn't work for this one, but you can pick if you want to know at what speed it hits the ground. You can pick a value like 12.9. You can pick this distance as 12.9. 12.9 and then square 12.9 squared. And if you plug in this thing, you know at what speed this top of a ladder hits the ground. That's pretty much. I just wanted to explain you how to use this formula. What's the use of this formula? It's just for calculating speed of this point. Okay, problem solved. That's it.